Hello, my name is Said Tabatabai, and this is my presentation for Lab 1 Digital Sampling for AE610. Firstly, we're going to be needing a definition for digital sampling. Digital sampling is basically whenever we're measuring a time-varying function using any digital device taking data from that function. Understanding digital sampling becomes very important when we're trying to read data from the sensors inside or outside of a rocket or an airplane. In this experiment, we're going to be using two different methods of digital sampling, which are direct input and an indirect input by using the microphone. By doing so, we were able to identify time-based waveforms, which consist of sine waveforms, square waveforms, triangle, ramp, product of sine, and sine of sine waveforms. The main instrument that we used in this lab was the LabJack T4 DAC, which came along with a microphone and an aux to analog adapter, which we used to connect the LabJack to a computer. And then on the computer, we used the GTAE Simple DAC software to try to identify the functions and read their frequencies based on the graphs that were drawn on the software. We also use an online tone generator to generate different sine waveforms for us to study in this experiment. And lastly, for the second part of the experiment, I used my acoustic guitar. There were three main parts to this experiment. The first one being the wave identification, which we identified the different waves provided to us based on their shape using a direct input. The second experiment was for us to validate the relative response of the microphone using 10 different tones at 10 different frequencies. And lastly, the third experiment, which we had to come up ourselves with, was the guitar experiment, where I measured the difference between the ideal notes played on an online guitar and the tuned guitar that I have in my house. These are my results for the first part of the experiment, where I was able to identify the type of a function purely based on its shape on the GTAE sample DAC. And these are my results for the second part of the experiment and the calculated relative response, which tends to be around 1.79, meaning that the microphone had a much higher response than the direct input. There are some discrepancies in the graph which can be contributed to possible errors caused by the laptop sound card or the surrounding background noise which might have been picked up by the microphone. For the last part of the lab, I decided to design an experiment which determined how accurately I can tune my guitar by only using my ears. I wanted to see if my brain could tell the difference between a perfect note and a close to perfect note. So then I decided to tune my acoustic guitar just by listening to the perfect notes on a website. After that, I decided to measure the frequency of the notes using the microphone and the lab jack that were provided in the equipment. As you can see on the slide, the tuned frequencies are about 14% lower than what it's supposed to be for it to be a perfect note, meaning that the guitar strings were just a little bit looser than what they're supposed to be. For my second experiment, I found out that using the direct input introduces much less noise into the equation, which results in a more clearer picture of the wave function on the simple DAC. Also, I found out that the microphone is much more sensitive to the sounds surrounding it, and it would pick up different frequencies, different noises at any point in time. For my third experiment with the guitar, I found out that the human ears, or actually my ears, are not quite completely sensitive when it comes to detecting small differences between the frequencies of the what I tuned the notes to be and what they should be. And thank you for watching my presentation and have a good day.